Hey, how's everybody doing out there? AP Calculus. Hey! I think I just broke something. It's a beautiful Thursday afternoon to do a little math here. AP Calculus, that's what we're here for. To review for the AP Calculus exam, which is how many days? How many? 70 days. So let's see. 70 divided by 7. 10 weeks. 10 weeks away. And this is the second to last show before a spring break, so it does not seem like spring out there, does it? So we are going to do a little fun today, a little fun with math, a little calculus. Yes, today for 1 hour, nothing but nonstop problems. So call on in 972-925-3123, and we'll give you some fun problems. Scott Kettner?
That's me.
You know what?
What's that?
In honor of you, I'm going to give you a PVA problem.
Okay.
Because you are the PVA man. Hey, you got that problem right on the calculus question of the week, man.
Did I win any money?
You're in the drawing. The winner will be announced at the end of the day.
Super.
All right. You, David Kent, Russell Blanchard, Butters, and Josh Newton that were the 5 students who got it right.
Great.
Pretty exciting stuff.
Yep.
How's life?
It's good.
Well, I'm glad. Okay, here you go. A particle moves along the x-axis in such a way that its acceleration anytime t for t greater than 0 is given by the accelerator at 5 over t squared when t equals 1 position of the particle is due to the velocity 3. When's the particle moving to the right? Scott Kettner!
When the velocity is positive.
Ding, 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 ding. Okay, so right away you say when the velocity is positive, right?
Integrate.
So how do we get the velocity?
Integrate.
What do you want me to integrate?
5 over t squared, the acceleration.
5 over t squared, so, and what's the answer to that? No pressure, no pressure.
It's 5t to the negative 2.
Okay, that's good. 5t to the negative 2.
So that's going to be, sorry, 5t to the negative 3 over 3. I mean 5t to the negative 1 over 5t to the negative 1 divided by negative 1.
Okay, what do I do from there?
Negative 5t. So you can put down negative 5 over t.
So negative 5 over t,
Plus
okay.
c.
Plus c, there you go. Don't forget the plus c. So what do we do from here?
Plug in what you have, the particle, and read again.
What?
Plug in 2 and 3.
The 2 and the 3?
Is that right? Yes. No. What am I missing?
Take your time. Are you calling from home or school?
I'm calling from home.
Okay.
I guess there's no other callers because you're not pressing me.
Well, no, there are callers, and you know it's. But you're Scott Kettner, the quarterback for the Seattle Seahawks.
I am. I'm scared about my job this week. All the quarterbacks getting cut.
I know. So hey, what does this say, Scott?
When t equals 1, the position of the
What are we trying to find?
position of the particle is 2. Oh, never mind. I see that. Never mind. I didn't see that. Okay. So plug in 1 for t and velocity is 3.
Okay. So what do we do from here?
Negative 5 over 1.
So we got c is equal to 8, and then what do we do?
Integrate again. Write down your
What's the question?
When is the particle moving to the right?
So if we're given the velocity is equal to this, what's the answer to the question?
Set equal to 0.
Right. We set this equal 0. So we're not. Why aren't we going to integrate again?
Because we don't need the position.
We don't need the position. That's right. Position's bupkis. That's for you, Scott.
Thanks.
Okay. So what do we do? What's the answer?
The answer is going to be 0. I mean, 8t is 8t equals 5.
So 8t equals 5. So what does t equal?
T equals 5/8.
5/8. So if t equals 5/8, how do we find when the particle is moving to the right?
Find out when the velocity is positive, negative.
Okay. So help me out.
All right. Anything less than 5/8.
It'd probably be easier to plug in a number greater than 5/8, right?
Oh, yeah. Plug in the little chart thing.
Scott?
Yes, sir.
So is the answer less than 5/8 or greater than 5/8?
Anything, Jeez, it's really blurry.
Plug in. Give me a number greater than 5/8.
2.
Okay. Well, how about 1? 1's easy.
1.
-5 plus 8's positive, so velocity is positive. The negative. So the answer is, it's moving to the right for t greater than 5/8.
Mm-hmm.
Pretty exciting.
Very excited.
Are you excited?
Very, very.
I feel good. I feel good. Is Allison watching with you?
She is, but she's too scared to call in.
Well, if she doesn't call in, tell her no prom for her. Okay. Call in again. Who's
will do
next? Alma Pacina!
Hello.
Ah, man, I hurt my own ear. I got your picture. Do you want with Joseph or without Joseph?
Either way.
Okay, we'll give you.
They're still cute.
We'll be independent today. What's that?
Nothing? Aw,
There she is! Alma Pacina!
Greg, can you do me a favor?
Yeah?
Instead of calling me Alma, can you call me another name?
What do you want me to call you?
Pookie.
What?
P-O-O-K-A-Y.
Pookie?
Pookie.
Pookie.
There we go.
Do you know I have a cat named Pokey? That's
But
true.
Pookie has another O.
Pookie.
Pookie. There we go.
Pookie.
Yeah.
Okay, here you
So
go.
take
Here-
note of that, you know.
And there's you and there's Joseph there. Okay. Hey, what'd you do? What'd you do in class today?
Inverse integration trig function.
Ooh, that stuff's hard, isn't it? Did you do you feel pretty good about that trig inverse trig integration?
The easy ones, yeah.
The easy ones. Well, what? Okay. Well, I don't know any easy ones, so let me give you. Let's try this here.
The hard one.
Okay, I'll tell you. You know what I'll do? I'll give you. I'm going to give you 3 problems here.
Thank you.
You have to, but you have to decide. You have to pick one of them, but you have to decide which one of the 3 is the trig integration.
The bottom one?
The bottom one?
No, because it has a 4. The first one.
The first one? Hey, you want to know? I know Ms. Brzezinski probably already told you, but you know the easiest way to figure this out?
No, she hasn't told us yet.
Well,
I'm playing.
sure.
It's 1 degree. And
If it, right, exactly. If it's 1 degree, so which exponent is more than 1 degree greater?
The middle one.
The middle one. Who said the middle one?
It was Angel.
Angel Acosta.
Sorry.
All right, it's the middle one. Okay, so what do we do? What do we do with this puppy then? First of all, is this arcsine, arctangent, secant? Which one?
Arc sign.
Arcsine. So what do I do? Help me.
You know what A is.
What is A?
So A is 1,
A is 1, okay?
and then U is going to be x squared.
So U is going to be x squared because U squared is x to the 4th, right?
Yepers.
All right, that sounds yepers. Pouquet.
There you go.
Pouquet. So
And then D is going to be 2x. D.
du
dx.
is going to be 2x dx. Okay, what do we do from there? Boy, this is getting easier, isn't it?
Sometimes.
What do you mean sometimes?
Okay, you're going to go. You have the 2x dx, so that's going to be du.
Okay, so we got the du on top. What do we got on the bottom?
So A squared minus U squared.
So what's the integral of du times square root of a squared minus u squared?
Arc sine
Arcsine of what?
x squared
Arcsine of u over a, which is just arcsine of x squared, right?
plus C.
Isn't that easy?
Yep. That one was.
Where's the...
Bell, there you
That
go.
one was? Okay, well, hey, Pouquet,
Yeah.
Pouquet, call in again, Pouquet, and we'll give you a little harder one next time.
All right, then.
Okay, thanks.
Thanks.
James Miller?
Hey.
Do I have a picture of you? Are you sitting next to Andrew? No, that's Nagler. I got a picture of Nagler. We don't want Nagler. Hey, what'd you do in class today? Have you done
inverse trig functions.
Have you done inverse trig derivatives?
Yeah.
Okay, try this one. Here you go. Try this problem. Ha ha. Who said ha ha?
Oh wow.
James, who said ha ha?
All the girls around me.
All, as usual. All of
Yeah. I think since they said that, you should show Gable's picture again.
Okay, well, I'll tell you what. You know what? I'm going to give you some inspiration. I'm going to give you some inspiration to
Okay.
To get the problem right. It's Molly! So,
That's a great picture.
okay, so what do we do? Little inspiration. Gable sitting on Mr. Irby's shoulder. That's
That's great.
okay. So what do you do here? Hey, what's the integral? Let me ask you a question. What's the derivative of e to the x squared?
X squared.
What?
No, it's e to the x squared.
Times.
2 e to the 2 e to the 2.
It's e to the x squared times what?
The derivative of the exponent.
Which is what?
2x.
Okay, using that philosophy, how would you start with this? What's the derivative of e to the arctan natural log of x squared?
That would be.
Using this philosophy, the derivative of e to the x squared, you said is e to the x squared times 2x.
Okay, let's put e to the arctan of ln x squared.
Okay, that's good. Now, and times what? The answer is
the
that.
derivative of arctan ln x squared.
And which is what? Now, what's the derivative of arctan? Do you remember the formula for derivative of arctan?
Isn't the derivative of u over 1 plus u squared?
Right, very good. So it's a derivative natural log of x squared all over. So it's a derivative all over 1 plus natural log of x squared quantity squared. So what's the derivative natural log of x squared?
2 natural log of x,
2.
which is.
So that's not the derivative. You just simplified it.
Oh yeah, it's 1 over x squared.
1 over x squared times.
2x.
So it's 2x all over x squared divided by 1 plus natural log of x squared quantity squared.
Yes.
So going slowly now, the derivative of e to the u is e to the u times the derivative of u. So what's the derivative of this? Well, it's 1 over 1 plus this squared times the derivative of this, and the derivative of this is 1 over x squared times 2x, which would simplify to 2 over x. You
Yes.
start to see that, James Miller?
Yes.
Isn't that pretty exciting?
Yeah, it's very exciting.
You know, fun with math.
Exactly.
And have one of the girls from Woodrow call in again. I got all their pictures.
Okay.
All right, talk to you later.
All right.
Bumika Kapatia!
Hi.
Hi. What?
That's Rachel, not me.
Is
Hi,
that-
Mr. Fly.
Hi, Rachel.
How are you doing?
I'm doing fine. Thank you for asking. Bumika Kapadia?
Yes.
I'm gonna give you Rachel.
hear.
Chill, Rachel. Chill. We'll give you. We're gonna give you a hard problem.
No.
Hey, that was pretty good. We'll give you a little inspiration. Your teacher.
My inspiration?
Your inspiration. It's like that movie with.
a room. 212 in art.
Okay, whatever. Okay, let's see.
Would you rather have? Okay, what do we want to do here? If we want to solve for y, what do we have to do?
You gotta separate your variables.
You do have to separate it, but this is where the hard part is.
You're wrong.
Shut up.
Hey, Rachel, calm down, Rachel. Calm down.
Excited. This is
I'm
right
down.
after the-
Okay. Let's see. You multiply. You get the dt on the other side, so you're.
Okay, so we got dy is equal to 16 plus, that's the 16 plus y times dt, right?
Right. And then you divide by 16 plus y.
Very good. Now, did you do that on
I
your own, or
told
did
her
you
that.
get help?
Both.
Both.
Yeah.
Okay, that's pretty good. See, that's hard to recognize, but you see where to go from here without any help?
Okay, you're gonna integrate now.
Yeah, what's the integral of this?
It is, hold on. I have to think about it.
Students, we're going to be locking up the building
Sorry.
in about 3 or 4 minutes, so you need to clear out.
Could you tell Miss Ramos not to interrupt my show?
Sorry, I can't hear you.
Could you tell Miss Ramos not to interrupt the show?
That wasn't Miss Ramos.
Okay, all right. Thank you, Rachel.
They think we're gang members. Okay.
Okay. So what do I do here, Bhumika?
You integrate both sides.
What's the integral of this? Bhumika, what's the integral of this?
It's gonna be natural log of 16 plus y.
Right. It's just u is equal to this, du is equal to dy, so it's just the natural log of du over integral of du over u, which is just the natural log of 16 plus y.
Right.
Okay. And we'll have some absolute values there. What's the integral of dt?
T.
T, and we got a plus c. What do I do from here?
You have to sub in for your let's see, put in your y.
Very good. So we got natural log of 20 is equal to c. Okay, now we got a little algebra action here. Natural log is 16 plus y. I know there should be absolute values there, but since we're dealing with positive things, we'll just leave it like that. So how do we solve? How do we solve? What's wrong with her? How do we solve for y here?
I can't see the t equals thing. No, the top, above Miss Arthur's head.
Oh. Find y when t is equal natural log of 2. Just find y first. How do you
Okay.
find y?
Miss Arthur said put in natural log of 2 first.
You're wrong. No.
Okay, let's solve for y first. If I want to solve for y here, Bhumika, if I want to solve for y here, what do I do?
Would you eat it?
I'd e it, right?
Okay.
Okay, now if she wants to plug in that, since we'll do what she says because you're welcome. So e both sides, so you got 16 plus y is equal to e to the natural log of 2 plus the natural log of 20. Well, how do you simplify this puppy?
Well, okay.
What's natural log of a plus natural log of b? Does that simplify to anything?
Okay. There's a natural log rule, right, when
Yeah.
you add them?
Yeah, but is this the rule?
What? I'm
What?
confused.
I know. The rule is natural log of a plus b.
I can't see that good. Okay.
I'm sorry, the rule is natural log of a natural log of a plus natural log of b is equal to natural log of ab, right?
So it's going to be natural log of 40.
So natural log of a plus natural log of b is natural log of 40. So therefore, we have e to the natural log of 40. And what's e to the natural log of 40?
Just 40.
Just 40. So what does y equal?
40 minus 16.
24.
Yeah.
Bhumika, hey, Bhumika,
Yes.
you get Rachel Kelly to call in next time.
Okay.
All right.
Change that for Anna.
Okay, all right, after Annalisa, I'm
Yeah.
sorry.
Okay.
All right, New!
Hello.
Hi, New.
Hi, how you doing?
I'm doing fine. Thank you for asking. That's very nice of you. Is Mr. Morrow there with you?
Yes, he's right here.
There's New!
Oh no.
Hey, what'd you do in class today?
We have class today. We have class
Wow,
yesterday.
what'd you do in class yesterday?
We're doing inverse trig function.
Have you done derivatives or just integrals? Or
We're on derivative right now. We do derivative.
just derivatives? Okay, I'm gonna give you a derivative one then. You ready?
An easy one.
An easy one?
I'm just kidding.
I don't have any easy ones here.
Okay.
We're winging this here. Arc sine of natural log of, how about tangent of x? Ooh. That looks fun.
Sure it is. Okay, let's see. Natural log of tangent x is so we use the derivative first for that. It's going to be u prime over
So what's the formula?
u prime over 1 plus u square for tangent.
Okay, so therefore, right, it's u prime, so it's the derivative of this all over 1. No, what's the formula? 1 plus? did
Oh,
you
I'm
say?
sorry. U prime square root of 1 minus u square.
Right, so we'll just do this first. And we'll put, and say,
Yeah, so u is that.
okay, now times the derivative of
Derivative
this.
of tangent
The derivative of natural log of tangent. What's the derivative of
Yeah.
natural log of tangent?
is over 1 over 10x tangent x
Times
times secant square.
secant squared x, right? And that's the answer. Now you could simplify this in terms of sine and cosine if you want.
Yeah.
How would we simplify this in terms of sine and cosine?
Tangent is equal to sine x over cosine x.
So 1 over it would be cosine over sine. And what's secant squared?
It's over 1 times cosecant square.
Times cosine squared.
Oh.
So
Okay.
you got cosine
Then
over,
you can cancel that out.
right, so it'd
So
just
you
be,
have 1 over sine x times cosine x.
so this would be your final answer. Very good. New?
Yes.
You want a bell?
Yes, please.
Hey, great job. No!
Thank you.
No, thank you. Thank you. Appreciate that. All right. Who's that?
Jamila.
Jamila from Molina?
Yeah.
Are you a Jaguar? Touchdown!
No. Why are you doing it?
How come I don't have a picture of you and Joseph?
Me and Joseph like that type. We're not that cool.
Okay, all right. Here you go. What is that sound effect? It's the derivative of natural log of sine e of x. Here you go. That's fun. I'll tell you, we'll do two of them, Jamila. We'll do two of them. You do this one real quickly, though.
Okay. First, the derivative of sine derivative. The derivative of sine e to the u is cosine e to the x
Times.
e to the x
Very good. Okay, so that's the derivative, and we put that all what?
over sine e to the x
And we could simplify this. If we wanted to simplify this, what would it simplify to?
cotangent.
Very good. Jaguar. Okay, here you go, Jamila. One more.
Okay.
Real quickly here. Let's make it look the same, but really not. Arc sine of e to the x. It looks the same, but it's not, as you well know. What's
Derivative of u.
which is what? What's the derivative of this? I know it's a derivative of u all over u. So what's the derivative of u?
1 over square root of 1 minus u squared.
And what's u squared?
I mean, e to the x.
That's u. So what would u
E to
squared?
the 2x.
Very good. E to the 2x. Excellent. Times
1 over.
no.
Oh.
The derivative of arc sine of e to the x is 1 over 1 plus u squared times the derivative of u. What's the derivative of u?
E to the x.
Right. Okay. Very good. And we put that all over arc sine of e to the x because that's what you said in the first place. Hey, Jamila, fine job, Jamila.
Thank you.
Do you know Pouquet?
Yeah, I know Pouquet.
Why she go by Pouquet and not Alma?
Maybe she like Pouquet better.
I don't understand. Hey, listen, good job. Call in again, all right?
Okay.
Is this Casey Brown?
Yes, it is.
Do you know Mr. Irby gave me like 10 pictures of you? You know that? Hold on for a second here. It's crazy. Hold on. We got you hugging people. We'll just provide 2. Actually, here's 3. Okay. We have 3 pictures of Miss Casey Brown. Where are you going to school next year? A&M?
Yeah, I'm going to A&M.
What are you going to major in?
Math.
There you go. No pressure. There she is, Casey Brown. There's 1. There's 2 with you and Sloan. And there's 3. Now, why Mr. Irby is taking so many pictures of you, I'm not really sure, but that's okay.
He loves me.
Well, you know, that's of course. So, what type of problem do you want?
An easy one.
An easy one. You guys. Hey, I'm gonna give you a pretty good problem here. It's
Okay, give me a good one.
It's really not easy though.
Okay, well,
But
you can
it's
help
okay
me.
because you're Casey Brown. All right. So if dy dx is equal to 4xy, you have to find y in terms of x if when x equals 1, y equals 0.
You split them, and you would hold on a second.
Okay,
Let me look at the problem we just did.
What's that?
Let me look at the. Did we just see a? Hold on.
Not really. There was no problem that was really like this.
Okay. I think that maybe you would multiply by dx on both sides, and get dy by itself.
Okay. So we got dy is equal. That's good. Good start. And what do we do from there?
Divide by y.
Divide by y. So we have dy divided by y is equal. Now, did you get that on your own?
Yes.
Yeah, very good. Okay. Now, who was that?
That was nothing. That was nothing.
Okay, that was nothing. So, what do you do from here? That's good. That's good, Casey.
Well, you integrate both sides.
Okay, what do we do from there? I mean, how do you do that? What's the answer?
Okay, well, that's ln of y. And that's 4x.
The integral of 4x?
Yeah, 2x squared. Sorry.
2x squared, okay. Now what do we want to do?
Do you do the E?
This,
E at both sides?
okay, we're going to make this 1.
Okay.
So e both sides, so you get y is equal e to the 2x squared plus c, right?
Right.
Okay, and then what do you do?
You plug in the numbers? Maybe? Yes?
What do we want to plug in? Hey, let's simplify this first. How would you simplify this algebraically? E to the 2x, e raised to the 2x squared plus c.
You'd bring the C down?
I'd bring the c down. Well, let me ask you a question. What is x squared times x cubed?
X to the 5th?
Okay, it's x to x to the 2 plus 3, right?
Oh, okay.
So how would you simplify
So-
this?
You're going to multiply times E to the C?
Right, it's e to the 2x squared times e to the c, and e to the c is just some constant. We could call it another c. It's like, this is e to the c is some constant, because c is a constant. So we'll just call this y is equal c e to the 2x squared. We'll call it, it's a different c, but we'll call it c because it doesn't matter. It's just,
Yeah, okay.
okay, and now what do we do?
Now you're going to plug in the numbers.
Right, so we got 1 is equal c e squared, so then you got c is equal 1 over e squared. So therefore, the answer would be y is equal to 1 over e squared times e to the 2x squared. You sort of see that?
Yeah.
Hey, I had a question. Why did I change this? This is really hard. I saw this was y equals 0, and it would work if we plug it in here, but why did I change it in the middle of the problem?
Because natural laws of y equals 1.
Well, because natural log of y has to be what?
1.
It has to be greater than 0.
Okay.
Okay? Then y has to be greater than 0. So if we had y equals 0, it's not even in the domain of the problem. So
Yeah, that's what I was thinking.
yeah, you know what? I figured that's what you're thinking.
Yeah.
You know? So that's pretty exciting. All right. Well, Casey Brown, make sure you call in again, all right?
All right, thank you.
All right. No,
Bye.
thank you.
Goodbye.
Okay. Is this the one who likes to argue?
Not anymore.
Not anymore. That's right. Put you in your math place, right? No, I'm just kidding. I think I have your picture here. Oops. Hey, how come you're not trying to answer the calculus question of the week?
I forgot.
You forgot? Andy! I'm not sure why they're doing that.
Who's that?
Nee?
Uh-huh.
Is that you?
Yeah, that's me.
We're just going to leave you up there. Actually, no, actually, you weren't up there. A little confused by this new arrangement. The, Nee?
Uh-huh.
What did you do in class?
Today, we just went over the inverse and different, I don't know, arcsecant.
You went over arctangent?
Yeah, I think we did that.
You think you did that? Did you do derivatives or integrals?
Derivative.
Okay, so therefore, if you not, what's the answer to this, Nee?
That is e to the x, e to the 3e to the 3x over 1 plus e to the 3x squared.
What's e to the 3x squared? Is it e to the 6x or e to the 9x?
That's e to the 9x.
What's, okay, let's, if it's
a
e to the
6x
3x squared,
Yeah.
what is it?
E to the 6x squared.
How do you simplify this? E to the 3x quantity squared.
How do I simplify that?
Is this answer, is it
Oh,
e
yeah.
to,
E to 9x squared.
is it e to the 6x or e to the 9x or e to the 9x squared? Which one?
E to 9x squared.
Okay, let me ask you another question. What's x cubed raised to the 4th?
That's x to 12.
How do you know that?
She multiplies power.
Oh, when you raise to a power, you just multiply, right?
Uh-huh.
So what's e to the 3x quantity squared?
Oh, e to the 6x squared.
Yeah, it's e to the 6x, right? Okay, good job. That was actually a little too easy for you. Call in again, I'll give you a harder problem, okay?
Okay.
Hey, good job, Nee. Good
Thanks.
job. Francisco, man, I gotta give him a hard problem. How you doing, Francisco?
Fine.
Since you, hey, how come you gotta go in and on the try to get that calculus question of the week? Some of those will even challenge you. I know who you are, with the Metallica man. Here you go. There he is, Francisco! Hey, have you? Metallica. I only know Enter Sandman.
Enter Sandman, yeah.
That's all I know. Did you do inverse trig integrals yet?
Just the derivatives.
Just the derivatives? Huh, okay. If you just did that, then... Well, actually, okay, I'm not going to give you one of those problems. I'm going to give you something a little harder.
Alright.
Just make sure that we understand the concept here. This is the same type of problem we had the first problem up on the show. It says a particle moves along the x-axis in such a way the acceleration is 5 over t squared. T equals 1 the position, particle is 2 and velocity is 3. What is the average acceleration of the particle from t equals 1/2 to t equals 1?
Okay.
How would you figure out average acceleration?
Take the integral of acceleration.
Take the integral of acceleration. Oh, by the way, earlier, okay, the integral of acceleration, and what does that tell us?
Velocity.
So why do we want the velocity? I'm not saying you're wrong, I just want to know.
Fine.
Help me out, Francisco.
Average value of function.
Very good, average value of a function. So average, if you have average, anytime you see the word average, you could use that formula, which is 1 over b minus a times integral from a to b of f of x. So if we want the average acceleration, we could take 1 over 1 minus 0.5 times the integral from 0.5 to 1 of 5 over t squared, right? Okay, now that's one way to do it. Anytime you see the word average, you could do that. And then we can integrate this. How do you integrate 5t to the negative 2?
Negative 5 over 3.
Take your time. Rewrite it first.
Okay, 5 times t to the negative 2.
Okay, so if we rewrite it first, we got 5t to the negative 2, and then what do we do?
Raise the power.
Okay,
by
so
1.
if you integrate this, what do you get?
5 or t.
What do you get when you integrate this?
Negative 5 over t.
I get 5 over t. Boy, you try to do. I mean, take your time. I mean, I know you're real smart, but try to just take your time and try to skip steps. But you were right. It's negative 5 over t. So it's negative 5 over t from 0.5 to 1. So this simplifies to just 2, and you get negative 5 over minus a negative 10.
Yeah.
Do you see why I get the negative
Yeah.
10? Okay. So then the answer is just 2 times 5, which is 10. All right?
Yeah.
Francisco,
Yes.
wasn't that fun?
Yeah.
Hey, I want to go back to this. I want to show you one other quick thing. What you also could have done, just like average velocity is change in position over change in time, average acceleration is change in velocity
Yeah.
over change in time. And notice it's the same thing as this, because when we integrate it, we get the velocity. And you're doing the same exact formula when you do the average value. You see?
Yeah.
So hopefully you see that, okay? Hey, great job, Francisco. Call in again, all right?
Okay.
Misty,
Yes?
I don't have a picture of you.
Oh, that's too bad.
I do?
No, you don't.
Oh, Misty Cobb.
No.
Misty Cobb, is it? I don't?
Yes,
I have you.
two pictures.
Well, hold on for a second. I have you a picture with Nina.
Okay.
Isn't that nice?
Take it off.
Wait, hold on for a second.
No, it's too long.
What's Joseph doing there? All right, hey, are you nervous?
No.
You're not? Okay, fine. There you go. Okay. Which problem do you want to do? The top one or second one?
The top one.
Okay, how do you do it?
Arc sine.
Arc sine of what?
Wait.
Ah.
Okay, A equals 1 and negative, no, U equals
Hey,
sine theta.
ask Miss Brzezinski what's the answer real quick.
What's the answer real quick?
She said no.
Okay, all right. Okay,
Okay.
it's the arc sine of what?
Okay, A equals 1
A equals 1, okay.
and U equals sine theta.
U equals sine theta, good.
And du equals cosine theta.
Du equals cosine theta, okay. All right. What do I do from here?
Okay. Arc sine.
Arc sine. So it's the integral of just du all over a squared minus u squared. So
Yeah.
the answer is arc sine of u over a, right? So what's the
Yeah.
final answer?
Arc sine. Sine theta.
Arc sine of sine theta. Who said that? Who said they cancel out?
Ms. Brzezinski.
They cancel out. So what is the answer?
Theta plus C.
It's theta plus c. Miss Brzezinski. Okay, now what we have the next caller is going to explain a different way to do this problem. But you're right, you did a great job on this, Misty. So it's and Courtney Barber from Woodrow is going to explain another way to do the problem. So Courtney,
Did you just call me Courtney Barber? That's the pre-cal teacher. Oh my god.
Courtney Cobell.
Yeah, you call me Courtney Barber. That's horrible.
Well, that's your physics teacher. I'm a little bit slow today, Courtney Cobell. The great Miss Cobell. I was just thinking that maybe your physics teacher is watching the How you doing?
I'm like offended you call me Miss
Okay,
Barber.
okay, we can get over it. I'm offended that I don't have your picture, but you know what? I do have a picture of
Mr. Irving. Oh.
Benray and Christian, and we have. Okay. Anyway, hey Courtney,
Yeah.
let's take a look at this problem here. This is not a calculus thing. How could we simplify 1 minus sine squared?
Cosine squared.
What's square root of cosine squared?
The what?
What's the square root of cosine squared?
Cosine.
Cosine. What's cosine over cosine?
1.
So what's the integral of 1 d theta?
X.
Theta, right, there's no x, so we'll just...
Yeah, theta.
Theta, so that's how you could get the answer instead of doing the arc stuff. Isn't that exciting?
Yeah, that is exciting.
I found it exciting. Try to do this other problem, Miss Cobell.
The one on the bottom? Wait, you want me to do the one on the bottom?
Yeah, do
Okay,
this one.
You do the u equals the sine of theta.
U equals sine of theta?
Yeah, and then du equals cosine.
Okay.
Wait, no, u equals 1 minus sine theta.
Who told you that?
No, wait, I knew that.
Okay, so what's du?
Cosine of theta.
What's du?
Negative cosine of theta.
Okay, very good. Negative cosine theta. So what do I do from there?
Okay, du over the negative cosine of theta equals d theta.
Yeah, I like doing it that way too.
Yeah.
Du
Over negative cosine of theta.
equals d theta, okay? So when you plug in this into d theta, you get cosine du over negative cosine, so it just this comes out to a negative du up here. When you plug this back in,
Yeah.
you know what I'm talking about?
Mm-hmm.
So you got negative du all over u to the 1/2. What do I do from here?
You move the u to the top and make it u to the negative 1/2.
Courtney Cobell.
Oh no.
That was so bad, wasn't it? You're embarrassed for me, aren't you?
Kinda.
Okay. So what do I do from here?
You add 1, so it's u to the 1/2 over 1. Which
Over
is
what?
basically-
U to the 1/2 over what?
1/2.
Yeah.
Plus c. Yeah.
So it's negative 2 square root of u, or negative 2 square root of 1 minus sine theta. Hey, that was really good, Courtney.
Thank you.
I'm serious. That was a fine job.
Thanks.
Hey, no, thank you. This is really exciting. Are you in the musical this year?
No, I haven't done that since freshman year. Can I see Mr. Irby's picture again, though?
Sure, we'll do that. I'll tell you, you know what? We still have 20 minutes left, so have another Woodrow person call in, and I'll show all Mr. Irby's pictures.
I'll make Gable call.
Yeah, have Gable call.
Okay, bye.
All right, bye. Preston!
Yes, sir.
Hey, I know. Are you the senior class president at WTY?
No, sir. Julie Fain is, and she's in here right now.
Did she?
I gave
I
my
thought
thumb up.
you were like junior class president, weren't you?
Yes, sir.
Did you run for senior and lost to Julie?
Yeah, I lost to Julie.
How are you doing?
What are you doing?
That's right. What are you doing?
Yeah, but you can pick up the quarters.
All right. I'm a little bit behind. Okay. Hey, I'm sorry that you lost, but I'm glad that Julie won.
Thanks.
How about
I
that for
appreciate that, Mr. Fleischer.
Hey, no, I appreciate you, Antoy. Hey, Antoy.
All right, here we go.
Hey, but seriously, how's Justice doing, by the way?
Hey, man, Justice is all right. Justice is pretty cool.
Is he? Okay, all right.
Yeah.
Pick one of the two.
Hey, guys, which one do we want to do? We want to do the bottom one.
We want to do the bottom
We'll
one?
take the bottom one for 200, Bob.
The bottom one for 200. Go ahead, Antoy.
All right.
It's an arcane.
Yeah, that's what he said. It's an arctan.
Arcane.
This is
saying it's
who says it's
arctan.
arctan? Wait, who said that?
Matt Plumley.
Well, Matt Plumley is just plumb wrong. Antoy?
Yes, sir. Okay, no, never mind. We're changing our answer. We're going to take the top one for 400.
The top one for 400.
Yeah.
What's the top one?
Daily double.
The Daily Double. Go ahead, Antoy. We got national sponsors wanting to contribute to this show.
All right, let's see. We're trying to we're thinking through this one here.
The arcane of e to the x.
Arctan of e to the x.
You just yell out an answer, Antoy. Come on, man.
Hey, that was mad again.
Okay, Antoy.
Yes, sir.
All right, Antoy. What if you know the final answer, which is correct? It is arctangent of e to the x.
Yeah.
What do I do? Plus c.
Plus c. Sorry about that.
So what am I going to do? What do I do?
U equals e to the x.
What?
U equals e to the x.
Because this is eu squared, because e to the 2x is e to the x quantity squared is e to the 2x.
Right.
So u is equal to e to the x, a is equal to 1. What's du equal to?
E to the x.
Right. So therefore it's just the integral of du all over a squared plus u squared, which is 1 over a arctangent of u over a, which is just 1 arctangent of e to the x over 1, right?
Exactly. I tried to say that, but you stopped me.
I know I did, but make sure you understand this, and Josh Newton from Science Engineering is going to show you how to do the bottom one, all right?
All right.
Hey, good job, Antoy. Later, dude. Josh Newton.
Yes.
Hey, you got that problem right on Question of the Week.
Okay, good.
Hey, where's Kyle, man? I got one for him to just blow his socks off or something like that.
He had to leave, but he gave me a problem to give you.
Okay, well, he has to give it to me direct, so try this one.
Okay.
The bottom one.
Well,
Take your time.
that's going to be du over u.
Okay, so what's u equal to?
1 plus e to the 2x.
1 plus e to the 2x, and what's du equal to?
2e to the 2x.
2e to the 2x dx. So, and then what do I do from there?
You have to correct it. So you have to put it's going to be 1/2 times the integral of 2e to the 2x over 1 plus e to the 2x.
So it's just the integral of what, in terms of u?
2 du over u.
2 du over u? Do you want this 1/2? I'm confused. Is it 1/2?
Yeah, that's right.
Is it 1/2 2? I'm not sure which one's right.
That's right.
This one's right?
Yeah.
Yeah, because you have to compensate for that too, right? And what's the integral of du over u?
Natural log of u.
Natural log of u, which is natural log of 1 plus e to the 2x plus
c.
Hey, quick question. I think I asked you this before, but if it's natural log, how come it's ln? How come it's not nl?
Because it's a logarithm.
Well, no. I mean, say, you know what I'm talking about? ln should be log natural. How come it's How come it's not NL? If you're saying natural log, how come it's not NL instead of LN?
I don't know.
Because Newton wrote in Latin. It's really logarithmic naturalis, something like that. That's
you
pretty
say.
exciting. Hey, real quickly, what's Kyle's problem?
The integral of x squared dx divided by the square root of 1 plus 2x.
Okay, that's not that hard, but it's actually outside the realm of the AP exam. But you'd simplify it in terms of u is equal to 2x. But I'll show him how to do it next week, okay?
Okay.
And I got a good problem for him. Tell him I'm not afraid of him, all right?
Okay.
Okay. Rachel Kelly, you're finally brave enough. You know what I'm going to do? I'm going to be gentle since you're...
Don't be rude.
Don't be rude?
Yes.
Okay, I won't be rude.
Okay.
Hey, wait a minute. You didn't do that. You haven't done this yet.
No. Anna said she gave up her call for me, so I can talk to you.
What's that?
Anna said she let me talk for her, so.
Well, we have a nice picture of Anna.
Oh, show it.
We have no picture of you.
That's because this is my first time.
And the only pictures, actually the only pictures we have of you are with Alex.
Oh, that's bad.
There,
Oh, look how cute she
isn't that
is.
a nice picture? Okay, you have to promise now to get no help on this problem. You have to do it all by yourself.
Okay. Okay. Okay, can I start talking?
Go ahead.
Okay, my u is going to be 4x,
Okay, u is going to be 4x.
and then my du is going to be 4dx,
Okay,
and then you have to times 4, and then a 1/4 on the outside.
so I'm having 1/4. What do I do from there?
Your little s thing, integration
Little
sign.
s thing?
Sorry, integration sign, and then it's sine u du.
Okay, and what's the integral of sine u?
It's cosine.
What's the integral of sine u?
Wait, it's negative cosine.
What's the integral of sine u?
What?
Which one is it?
Negative.
You sure?
Yes, absolutely positive.
How do you know that?
Because I'm smart.
Okay. Negative 1/4 cosine of u.
Wait, yeah, okay.
Right?
Uh-huh.
That wasn't so bad, right?
Yeah.
Pretty exciting, wasn't it? Now, was that a soft landing for you?
Was that a what?
Soft landing.
What was that?
I don't know. Well, it was a duck.
Okay.
We called Delbert. Delbert's the producer, Rachel. Hey, Delbert, after the show, I'll tell you who Rachel really is.
What?
Okay. Hey, that's a fine job, Miss Kelly.
Thanks.
Hey, no, thank you, all right?
Okay.
Call in again.
I will.
Please do.
Okay.
Bye.
Bye.
Hello?
Hi, Miss Fletcher.
Who is this?
It's Doe.
Doe?
Yes, sir.
Who, are you with Miss Johnson's class, right?
Miss Johnson, not Miss Cuman. Human, something like that, no.
What's that?
Miss Johnson.
All right, fine. I think I have your picture.
Yes. Remember last time, long time ago?
You're up in the trees!
That's me.
That is you. Okay. What do you want to do here? I don't know. What do you want to do here? Hey, I got a great problem for you here.
You know, Miss Fletcher,
Yeah?
I'm not good at this stuff.
But you're going to be.
Oh,
you-
okay, so
you
I
have
need
Miss-
your help.
You have Miss Johnson? You want to see a picture of Miss Johnson?
Yes, no problem.
There she is right next to you!
Yeah, Miss Johnson, no!
Not here.
Okay,
She's out this time.
What?
She's not here today.
She's not here today.
Yeah,
Okay,
because
well-
she got a meeting.
Hey, I want to find Y here. Tell me what I do.
Why? Oh, okay, just dy equal to ky times dt. Is that right? And then you try
What? So what do I do?
dy equal ky times dt,
Uh-huh.
and divide by the is it y? Yeah, dy over y equal k dt,
Uh-huh.
and now you want to find c, right? It is the natural law something of help me out, Mr. Fletcher. I'm not good
What's
at
the integral of dy over y?
It's the natural law, right?
Right, natural log of y, absolute values. What's the integral of k?
K.
What's the integral of k dt? Hey, what's the integral of 2 dt?
2t, yeah, 2t.
What's the integral of k dt?
K plus T.
K-
I know, just KT.
KT, right, KT plus C. Okay, how do I solve for y?
For Y, you take the integral of it, right? No, the E function. E.
Yeah, E
For Y,
something.
yeah, E function. I told you I'm not good at this.
You're
so.
doing fine. You're doing well. You're doing well.
Okay. So Y equals E to the KT plus C. Is that right?
Okay, now how do I simplify this?
Simplify it. Okay. What
How do I simplify e to the KT plus C?
is it E to KT times C to the times E to the C.
Very good, excellent. And we're
Okay.
going to call e to the C another type of C, because e to a constant is still some constant.
Is
So the
that
answer,
right?
the answer is this.
So that's the answer.
That's the answer, right? Because e to the C is that. Now what you're going to learn is this is a famous formula that if you have dy dt is equal to ky, it's called the law of exponential change. This is how you figure out population growth and a whole bunch of things. If you have dy dt equals ky, then automatically y is equal to c e to the kt, where you learn that c is the initial amount of y.
Oh, okay.
Pretty
thank
exciting stuff, right?
You. Yes.
Well, don't you think that's pretty exciting, Doe?
Yes. Thank you.
No, thank you, Doe.
Okay. Bye bye.
Bye-bye. Christian, I got your picture.
Well,
What's going on?
well,
Hey, were you
just
able to
saying
follow that
calculus
last
theory.
problem?
Yeah, I'm ready.
Yes!
All right, could we see now, please, the picture of Mr. Irby?
No, yeah, okay, that's right. I did promise. We got a couple pictures of Mr. Irby here. We got
Could we see all of them, please?
we got two. This is his I don't know the answer for look. And this is his I didn't get any sleep last night look. That's a very nice picture. Okay, hey,
Yeah.
what type of, you're really smart, right?
No,
No, I heard that you are.
I suck in calculus.
I don't think you can use that word. No,
I
hold
just
on.
learned it
Maybe
over
in
here, you know.
Germany, in Germany, you can use that word. You're not allowed to use that word here. What do you think this is?
USA. Texas.
USA, right. Did you see the 1980 U.S. Hockey Olympic team?
No.
Oh, that's right. Okay, anyway, here we go. You ready?
Yeah.
Let's just give you a straight E problem here. How about y is equal e to the x over x? I want to know when y is increasing.
When y is increasing?
Yes.
Okay, so we take the derivative.
So what is that?
That's a good question.
Well, thank you.
The derivative is Hody high minus Heidi ho over ho squared.
Hody eye, baby! Start with the ho!
Okay, so it's x times e to the x minus e to the x and all that over x squared.
Very good, okay. Now what do we want to find?
We want to find all the places where it's equal to 0.
Okay, how do we do that? We also want to find when it doesn't exist, but
Yeah, that's
but
true.
we don't care about that because it doesn't exist at 0. Why don't we care about 0?
Why do we care about
Why
it?
don't we care about when x is equal to 0?
Because the initial function is not defined.
Very
at
good,
0.
man. Christian, man, you use bad words, but I'll tell you, you're pretty strong there. So how do we find when this is equal? When a fraction is equal to 0, the numerator is equal to 0, right?
Mm-hmm.
Isn't that true? So how do we set this equal to 0?
Well, e to the x is never equal to 0, so
Well, what we want to do is
I
we
think
want
it's at 1.
to set this equal to 0. What do we want to do from here? I'll give you a good word. It's the F word. What's the factor
Yeah,
word?
factor it out.
So we're going
So
to
it's-
factor out e to the x.
Yeah, so it's x minus 1 times x minus 1.
Okay, and when does
Equals 0.
so it's when does e to the x equal 0?
Never ever.
Never ever. Exactly. It's always what?
Okay.
It's always
And,
that's not always okay. It's always what? Positive.
Yeah.
So the answer, the function is equal to 0 at x equals 1, right? So
Right.
when is it increasing?
Let me think real quick. when it's 2, the whole thing is going to be positive.
If you plug in a number greater than 1 into the derivative, what do you get?
A positive number.
Right, so it's positive. If you plug in 1/2 into the derivative, if you plug in 1/2, you have a positive times a negative, so it's negative.
It's negative, right.
So the
So it's
function is-
increasing for all x greater than 1.
Excellent job. Increasing for all x greater
Okay,
than 1.
can I get a bell, please? There we go.
There you go. You have a Courtney Cobell. Pretty bad, isn't it, Christian?
Yeah, it is.
Okay. All right. Well, listen, good job, and call in again next week, all right?
I will. Bye-bye.
Alan DeBard.
Yeah, actually, we decided to change of contestants. This is going to be B.
It was going to be who?
It's me, Mr. Fleischer.
Butters. It's Butters. Hey, okay, here we go. Alan, you got to pick one question, and you have 2 minutes
Alan?
to do it. Oh, Butters?
Yes, I'm doing the problem.
Oh, Butters, if you're doing it here, I don't know, these are too easy for you. Pick one.
That's fine. That's fine.
Pick one, Butters.
No.
Butters, pick one.
Okay, what do you want me to do?
Give me the answer real quickly to, I'm going to change this to this middle problem. Give me the answer real quickly, without
All
even
of them?
thinking.
The middle one is going to be arctangent.
Well, give me the whole answer.
The whole answer?
Yeah.
Oh, God. Okay, put the 2 in front.
All right?
So you get 1 over 4 plus x squared, which is going to be 2 over 2, which is 1, arctan of x squared over 2.
Arctan of what?
X over 2, sorry.
Hey, Butters, that's pretty impressive.
So it's 1 arctan x over 2.
That cancels
Plus
out.
C, I always forget the C.
Butters. She's Butters. Hey, Butters,
Yeah?
you know, you got the problem right last week, and you're in the drawing with 4 other students to win the $10.
Cool.
Isn't that pretty exciting?
So when are we going to know that?
When are you going to know it? You're going to know it right now. Hold on for a second. I'm going to, Butters,
Yeah.
I'm going to write down the 5 names that you won't be able to see, and you are going to pick a number 1 through 5.
Okay, cool.
Okay, and this is in no order. This is the order that I received the answer. And it's like, I won't read the names.
Like, how old are you?
What did he say?
Yeah, answer is how old you are.
How old am I?
Yeah.
Old enough to remember the USA hockey team. You got to see that HBO special.
1996.
Okay, Butters,
Yeah.
I got the thing. Pick a number 1 through 5, and this is who wins the $10.
4.
4, the winner is Russell Blanchett from BA.
Wow. Oh my God, he put Butters on there.
Butters. Okay, Butters.
Man, a friend told me to pick 3, but that's okay.
Well, you know, you lost $10 on that. Okay. Hey, we're gonna do this problem real. Actually, I don't. How much time do we have? Delvin?
We got like 3 minutes.
Hey, we got official cable time here. We're official people. Okay.
Okay.
Okay. Hey, Butters.
Yeah.
We only have a little bit more than a minute. So what we're going to do is, you're going to read this for us. You're going to read this for us and tell everyone that they could go to the calculus question of the week, or you go ahead and try to promote this.
Okay, so if you want to get $10, people, just go to their website and solve the problem. It's easy, trust me.
It's easy. Now this week, Butters,
What?
this week is a 2-part question. Part 1 is it is a very hard question, but part 1's a lot easier than part 2. So you have to get both parts. If nobody gets both parts, we'll just put a drawing in for the people who get the first part, okay?
Cool. I'll try to solve it.
Hey, Butters, where are you going to school next year?
SMU.
SMU, what are you going to major in?
Probably electrical engineering.
Electrical engineering? You're going to get a 5 on the exam?
Of course.
What other AP exams are you taking?
Huh?
What other AP exams are you taking?
Probably statistics.
Probably. You better take statistics, otherwise Mr. Brown's going to beat you up.
Oh, yeah. Okay.
All right.
I'll take it.
Well, listen, have a good week. Make sure you call in again next week before spring break, and we'll talk with you soon, okay?
Bye.
Bye.